Now, to start off this presentation, prior to any pipelining, the first thing that we're going to do is clean and remove any debris from the existing pipeline. Now, we don't care if you have hair-like roots, missing sections of pipe, but what you don't want is a root mass or any broken sections of pipe in that pipeline. You are putting a soft felt liner material in an existing pipe substrate, so we don't want it to take the shape of anything that's in that pipe. Even if I am missing sections of pipe, once the pipe has been lined, the liner itself is a true structural repair, so we don't care what happens to the original pipe substrate. This material is Uniform Plumbing Code approved, International Code Council approved, NSF Standard 14 approved, and everything's completely compliant to the ASTM F1216 specification for a minimum life expectancy of 50 years. Now, in a typical installation, what we would do is we would clean a pipeline. We would cut our liner material to the length of pipe that we want to line. Now, we don't go off the footage counters on cameras because they're not 100% accurate. So we take a literal hard mark for our length of pipe to be lined, and we're going to cut our liner material to that length. The liner material that we're primarily using is going to be a 3 millimeter thick needle punch felt with a PVC flex coating on the exterior. We also incorporate a reinforced scrim layer underneath that material, and what that's going to do is help us eliminate stretch. Because we are inverting a soft felt material, it has to be flexible, but we don't want that to stretch. Anything that's going to stretch not only in diameter can also stretch in length. If it stretches in length, we can miss our mark and we could end up blowing into the city main lines. Now, once we've cut our liner material to the length of pipe that we want to line, what the guys are doing is they're mixing up their 100% solids epoxy resin. The reason we utilize the epoxy is it's a 0% shrink, as well as you'll notice also, it doesn't contain any VOCs or volatile organic compounds. You can really tell though, I mean, anyone that's ever been, around a styrene, a resin that includes styrene, like your polyesters, your vinyl esters, you know that smell, that styrene smell. Anyone that's ever been in a boat shop or anywhere where they're doing surfboards, wakeboards, anything like that. The epoxies are really nice if you're using in confined space, delicate areas such as hospitals or inside restaurants, because it doesn't have that alarming odor, as well as it's not a flammable material, and it can be very easily manipulated. Whether you need to warm it up on a very cold day or cool it down on a very, very hot day, you can gain additional working time. And we do manufacture the resin or blend it in 3 different ways. We have a hot weather for 70 degrees and above, a warm weather from 70 to 50, and a cold weather for 50 and below. And what this is going to be is your amount of your catalyst. You're looking at your ambient air temperature outside. You're not going to look at what's in the ground because you're going to have a constant temperature in your ground and in your pipe. And that's just the amount of catalyst that you're utilizing. Now, we also have what we call a heat assist resin. The heat assist resin, you're going to have to promote with an external heat source such as steam or hot water, but it's going to gain you a lot of an additional working time. What's really nice about using an external heat source is you can use the same amount of catalyst in your resins year round and get a consistent cure time. Also, if I'm going to have a pipeline that has other lines that tie into it, you don't want your liner gummy or not 100% rock solid when you go to do those reinstatements. And we do distribute reinstatement equipment. We distribute equipment sold or manufactured by Dan Cutter, IMS Robotics, backside reinstatement equipment from Pacote Solutions. And these are very, very effective ways to open lines back up that have been lined over. This isn't squeegeing the epoxy into the felt. The vacuum's doing a majority of the work. And like I mentioned before, the guys are just looking to ensure that there's no dry spots in that felt. And this is going to be a complete visual inspection process. You're visually inspecting as you wet the material out, but you're also visually inspecting for your post-video inspection. And that's something that you will be able to visually tell if there's an area that there is not epoxy in that felt from the post-video inspection. Some municipalities I know, primarily on the West Coast, will actually require a before and after video for your permit process. Now, in a typical application, if I was to wet out my material, just blow the line, say from an access point like in a pit or in a manhole, the liner's gonna blow all the way down to the end, blow open, and it's gonna collapse. Once it's collapsed and in place, we're gonna blow through what we call a calibration tube. This is gonna act as our bladder or balloon to hold the air pressure for 3 hours while it cures, and will be removed and discarded. But we can also increase that speed by adding an external heat source, such as steam or hot water, and get that cure time down to as little as 40 minutes. And we do manufacture turnkey trailers that we set up for those hot water or steam cures as well. We actually have one here behind us. If anyone wants to walk through that after the demonstration, we'll be happy to walk you through it. But in that typical application, I would do a two-part. I would blow my liner, then blow my calibration tube, allow it to cure, and pull this back out. Now, the process we're showing today is going to be a little bit different. This is a patented process, which we call our tearaway process. Now, in your typical installation, you would blow your liner, then blow your calibration hose. Here today, what we're doing is we're using a translucent calibration hose so that we can actually see through it. It's going to be sleeved over top of our liner material. We actually cuff it back and adhere these two together with a special adhesive. What we're demonstrating today is going to be that we can start our materials, come down through this T, and we have a patented directional shoe that looks basically like a giant shoehorn. And you're going to have nothing but your bladder, bladder, bladder. It's going to go through this shoe. And about this area, we're going to start the liner and calibration tube inverting together. This is going to allow us to start and stop our liner anywhere we want in this pipe. Coming directly through a T fitting, we can do directionals, we can do two-way cleanouts, and we're not going to line over the back side of this pipe. If we were to just typically blow the liner material straight down, it's going to deadhead at the bottom of this fitting, and it's going to stop. So that's why we use that directional shoe. Now, once he cuts that off, that's where his adhesion joint is. Remember, I called this process our tearaway process. The reason we call it our tearaway process, or even a remote start, once they've got their material cut off past that adhesion joint, they're gonna uncuff that material and attach it to our inversion head so that when they introduce air pressure as this goes through, you're gonna have your calibration hose comes directly down that vertical stack through that patented shoe, and then your liner and calibration hose are gonna start inverting together. And you'll be able to visually see this through the acrylic pipe. At the other end, the material is gonna be knotted, and that's gonna allow us to hold our air pressure. If we were gonna do this with steam, the other end would actually have a grommet that's gonna allow the steam to port through. And once this is fully cured, we're gonna use our blue pull strap to pull that material back out, and it's gonna peel it away, and we'll be able to discard that material at that point. Now, what you don't wanna do is try and reuse calibration tube, especially not calibration tube that we've already used an adhesive to attach the two. Okay. Now, if I was to have a belly in this pipe or something that's holding a great deal of water, what I don't want to do is put the liner in too quickly, because the liner is going to take the path of least resistance, so we could actually jump that holding water and create a lift or a pocket in the pipeline where we trap that material. The reason we call this a tearaway process is because once this is fully cured and we start to reel back our blue pull strap, we're going to actually pull this back. It's going to remove the bladder from inside. When it hits our adhesion joint, we're just going to tear that joint away. You won't be able to even tell that anything was adhered to it. And we can start and stop this liner anywhere we'd like to in that pipeline. And this is actually a truly trenchless process. This as well is something that we do provide training and certification on all of our products, and we actually do that out in the field. And this is a process that we do train and certify on at your location out in the field when we train and certify you. Perma-Liner ourselves, we are not actually an installation group, so we don't actually compete with our installers. We manufacture the materials, the equipment, provide the training and certification, and all the 24-hour technical support, as well as, you know, anything you could ever want for marketing, everything from door hangers to signs to website graphic design, pay-per-click campaigns, end-user DVDs, brochures. Now, once the guys have this fully band strapped down, they're gonna take the other end of their calibration tube, cuff it back over the end, and that's where they're gonna knot it. So as this inverts through, your first section that's gonna go into our existing pipe is gonna be coming from our inversion head, and the tail that is knotted is actually gonna be protruding past the end of our liner material, 2 feet. And that's what's gonna hold it open at the end while the material cures. Your typical cure time in an ambient cured environment is going to be a 3-hour cure. But like I was stated earlier, if you want to speed that up, we can introduce hot water or steam, get that down to as little as about 45 minutes. Yeah. You can see the one that I laid down here from the heat, because it is in mass and it's in direct sunlight, it doesn't have the ground act as a heat sink. It's actually ballooning up because it's expanding those air molecules inside of it, because that is probably about 210 degrees right now. It's very hot to the touch. When the liner inverts into the existing pipe substrate, you have the ground that's going to act as a heat sink and not allow it to get as hot. I wouldn't sit on that thing, Morgan. Don't let it touch your leg. You use it as a curling iron for Andrew. Now, the blue pull strap actually is going to serve 3 purposes. It's going to allow us to coerce that material inside of the air inversion unit around the interior spindle. It's also going to allow us to control the speed that we invert our material throughout this existing pipeline, because if you were to have groundwater infiltration, what you don't want to do is to blow a liner, stop, blow, stop. What'll happen is you'll trap it. You'll create a lift or a pocket inside of that, in between the pipe substrate and the liner material, which is going to be an area that constitutes a failure. So it's going to allow us to control our speed, removing any water there or that may be in that pipeline, as well as it's going to, it is cut job site specific. So when we know that we get to the end of our sight glass, or our blue pull strap looking through our sight glass window, we know that our liners, or excuse me, our bladders protruded past the end of our liner. And then it's also going to allow us to pull that bladder back out and tear away that adhesion joint. Now, with Steven spraying on the material as he rolls it up around the spindle, it's simply vegetable oil. We are inverting these materials, and we're inverting them together. So friction is going to be your enemy. We're trying to reduce friction as much as possible. So we use a simple vegetable oil to reduce that friction. Now, what Chris is applying on the bottom is just a guide hose. Because we're just putting our bladder straight down our vertical stack through that shoe, we want to make sure that our material's protected outside of the pipeline, as well as everything's cut job site specific. These units do go up and down and pivot in different directions to make it more convenient depending on your job site access. So they want to make sure that they stuck with their measurements they took directly off their camera cable as well. So as they introduce the air pressure, they'll get down to the bottom, and you'll see that Steven will actually coerce this through that directional shoe that's at the base, at which point the materials will make that bend, and we'll begin starting. You'll see that there'll be a little bit of calibration tube, and then they should start somewhere in this pipeline where you'll be able to see that the materials have inverted together. So what Chris is doing is he just wants to make sure he's positioned that shoe properly. If they were to turn the shoe around the other direction, we could shoot the liner back up under the property. So there, now that needle punch felt liner material, there was the PVC coated material that was holding the resin in place has inverted inside out so that your resin is in contact with your existing hose pipe, and your PVC flex coating is becoming your new inner pipeline wall. Now you notice also that as he did this, Steven never looked at this pipeline. This is all underground. So he's doing everything by looking through the sight glass window on his inverter. This is a truly trenchless process, and that's why everything is cut so job site specific. We actually fill out field installation sheets that walk you through step by step all of your measurements. All of the resins are weighted out, pounds per linear foot. They come in 5-gallon buckets, and you can actually pour those to weight, measure it out. It walks you through the length of pipe you need to line, your length of your calibration tube, your resin calculations, and your pull strap calculations, so that you can have everything 100% for that job. At this point, what the guys would do is let this sit for a period of 3 hours, but if they wanted to take their machine and go do another line, they could do so. They can actually pinch this material down outside of the pipe, release the material, release the air pressure from the machine, put a cap in the back of that inversion head, and hook that up to an air bottle and a regulator and move on to the next line. Now what the guys are doing now is we have also a patented inspection port that's hooked up to our air inversion unit. If they want to inspect this line to make sure that they hit their desired points, they can actually do so while the inversion unit's under pressure. So Chris has actually got his camera going through, and he can push this all the way down to the end and make sure he started and stopped exactly where he wanted to. So at this point, it's primarily a waiting game. Once it's fully cured, they'll remove that bladder, tear away the adhesion joint, and move on to the next job.